You've probably heard of black holes, those mysterious regions in space where not even light can escape. Black holes are areas of space with such intense gravity that nothing, not even light, can break free. But could there be a hidden doorway that leads to an entirely different universe through a black hole? Could we actually travel between universes through these cosmic gateways? Today, we're going to dive into a thrilling theory that black holes might not just be the end of everything we know, but could instead be gateways connecting different universes, worlds we have yet to even dream of. Scientists have studied and proposed that black holes may not only be places where matter and light are swallowed, but they could also be the links to parallel universes, or even alternate spaces and times we cannot yet comprehend. If this theory is true, black holes might not be the end of something, but part of an endless cycle, where new universes are born from black holes. Why does this matter? If we can understand how black holes work, and the possibility that they could connect with other universes, we won't just change how we think about black holes, but it could also open a new era in the way we explore the cosmos. This could change the way we think about space and time, and help us answer big questions like, how many other universes are out there? Is our universe just one of countless others? Let's dive deeper into this theory and explore whether black holes might really be the cosmic gateways to other universes that we have yet to fully uncover. We've all heard of black holes, but what exactly are they? How can a region of space possess such immense power that nothing can escape from it? A black hole is a region in space where gravity is so strong that nothing, not even light, can escape. Once something crosses the event horizon, it's pulled in and trapped. A black hole forms when a massive star dies and collapses under its own gravity. When this happens, all the mass of the star gets compressed into a point with incredibly high density, and this is what forms the black hole. Stellar black holes are the smallest type, typically forming when a large star collapses under its gravity. These black holes are usually between a few to a few dozen times the mass of our sun. Supermassive black holes, as the name suggests, are incredibly large. They can be millions to billions of times more massive than our sun. These massive black holes are typically found at the center of galaxies, including our own Milky Way. These are extremely small black holes, but with incredibly high energy. They could potentially be created in particle accelerators, although they haven't been observed yet. Every black hole has a boundary known as the event horizon. This is the point beyond which nothing, not even light, can escape. Once something crosses this point, there's no turning back. At the center of a black hole lies a point called the singularity, where all the mass is concentrated into an infinitely small point with infinite density. At this point, the laws of physics as we know them no longer apply. Black holes don't just trap matter, they also warp the fabric of space-time itself. This phenomenon, called space-time curvature, was predicted by Einstein's theory of general relativity. So can we survive passing through a black hole? Or is it just a tragic end for anything that ventures too close? Scientists are still debating this possibility. One of the most fascinating hypotheses is the idea of wormholes, tunnels through space-time that could potentially link black holes to other regions of space, or even other universes. So as we've seen, black holes are not just dark, mysterious regions of the universe, but incredibly complex phenomena. Their properties, from the event horizon to the singularity, make them one of the most fascinating objects in astrophysics. While we may not be able to travel through a black hole just yet, understanding them is crucial to unlocking many of the universe's greatest mysteries. Questions like, how many universes are out there and are we living in just one universe, have always intrigued us. In recent years, scientists have introduced an interesting hypothesis, the multiverse theory. The multiverse theory suggests that besides our own universe, there could be countless other universes existing simultaneously. Each of these universes may have different physical laws, creating entirely different worlds from ours. There are several versions of the multiverse theory, including The interconnected multiverse, parallel universes that exist independently but interact with each other. The infinite multiverse, an endless number of universes in an ever-expanding cosmic space. The level multiverse. Each universe may have its own distinct set of physical laws, creating entirely different conditions for life. So how do black holes relate to the multiverse theory? Some scientists believe that each black hole could be a gateway to another universe. When matter falls into a black hole, it could pass through a wormhole, a space-time tunnel, leading to a parallel universe. One intriguing theory is the Big Bounce. According to this theory, each universe could be born from a black hole in a previous universe. Universes continuously expand and collapse, creating an endless cycle of rebirth. The famous physicist, Kip Thorne, has proposed that black holes may not just be tools for studying physics, but could be gateways to parallel universes. Today's experiments and computer simulations have helped scientists study the connection between black holes and the multiverse. Some research on space-time wormholes has suggested that black holes could connect distant regions of space, or even lead to other universes. Some experiments at CERN, where scientists conduct particle physics research, are also looking at creating mini black holes. These could help us better understand how black holes work and how they might relate to other universes. So could we one day use black holes or wormholes to travel to other universes? This question remains a hot topic of debate among physicists. While we don't have the technology to travel through black holes yet, studying these possibilities opens up exciting prospects for the future of space exploration. The multiverse theory opens up a vast and fascinating imagined world, and linking it with black holes is both mysterious and promising. While much is still unknown, exploring the connection between these universes could help us better understand our own universe. Perhaps in the future, black holes will not just be mysterious points in space, but gateways leading to other universes we have yet to discover. So, if black holes could be gateways to other universes, how could they work? One fascinating scientific theory related to black holes is wormholes, also known as space-time tunnels. Wormholes are essentially holes in space-time that could connect two very distant points in the universe. They act like a shortcut between two regions of space, and in theory, could even connect to another universe. Simply put, a wormhole can be thought of as a tunnel in space-time that helps reduce the vast cosmic distance between 2 points. One intriguing hypothesis is that every black hole could be a type of wormhole, connecting one region of our universe to another. As matter falls into a black hole, it could pass through a wormhole and emerge in a parallel universe. Could we one day travel through wormholes? This is a question that scientists and theoretical physicists have debated for many years. In theory, wormholes could allow us to travel through space and even through time. If wormholes really exist, they could serve as portals, enabling us to travel to parallel universes or reach distant regions of space in an incredibly short period of time. However, traveling through wormholes is not without its challenges. Scientists believe wormholes would be highly unstable and may not be large enough to allow a spacecraft to pass through. Additionally, it would require an enormous amount of energy to create and maintain a wormhole. Although wormholes are still theoretical, scientists have conducted several studies to explore their potential existence. Some research in quantum physics and general relativity has suggested that wormholes could form under very specific conditions, such as in black holes or during events like the Big Bang. Alongside theoretical research, experiments at CERN are also looking into mini black holes, which could help us understand how wormholes and black holes form. Perhaps one day, when our technology becomes more advanced, wormholes could become a tool for space travel. Could we use wormholes to travel to other universes or even through time? This remains an unresolved question. Although we don't have the answers yet, studying wormholes and black holes is crucial. It could not only help us understand our own universe better, but also open the door to exploring new realms beyond our imagination. Black holes are not just dark points in the universe, but potential gateways to other universes. Wormholes might be one of the possible paths that allow travel between parallel universes, though many challenges and mysteries remain. While we may not be able to travel through wormholes today, researching them will certainly pave the way for a future where we can explore new universes beyond our own. Black holes are more than just cosmic objects with immense gravity. They are the ultimate distorters of time and space. In fact, they bend the very fabric of the universe around them, creating one of the most intriguing phenomena in the cosmos. According to Einstein's theory of general relativity, space and time are interconnected in a fabric known as space-time. Imagine it like a stretched rubber sheet. The presence of mass, like a star or black hole, causes that sheet to warp. When we talk about black holes, we're talking about massive objects that create such a strong gravitational pull that space-time itself is heavily distorted. This is why they are often called the ultimate space-time warpers. The closer you get to a black hole, the more intense this distortion becomes. One of the most fascinating effects caused by black holes is gravitational time dilation. This refers to how time moves differently depending on how strong gravity is at a specific location in space. Imagine you are standing near a black hole. Time for you would appear to pass much more slowly compared to someone far away from the black hole. This means that if you were to spend time near a black hole and then return to Earth, you could find that centuries have passed for those who stayed behind, while only a few years may have passed for you. This phenomenon has been observed in smaller forms on Earth, such as with GPS satellites, where the stronger gravity at Earth's surface causes clocks to tick slightly slower than those in orbit. In the case of black holes, the effect would be far more extreme. At the event horizon of a black hole, time could essentially come to a standstill for an outside observer. But for the person falling into the black hole, time would seem to move normally. Now, let's talk about how time dilation ties into the concept of time travel. Time dilation near a black hole could, in theory, act as a kind of time machine. By spending time near a black hole and then returning to normal space, you would have effectively traveled to the future. The closer you get to the event horizon, the greater the time dilation. Theoretically, if you were close enough, you could witness the entire future of the universe unfold, while only a few hours or days pass for you. While the concept of time travel to the future is fascinating, we currently lack the technology to survive near a black hole. The immense gravitational forces would crush any spacecraft or human that gets too close. However, the theoretical framework around time dilation is sound, and scientists believe that given the right conditions, time travel to the future could one day be possible, albeit in a very limited form. Another fascinating idea is the connection between wormholes and time travel. Wormholes are not just potential gateways to other universes, they might also serve as time machines. The idea is that if wormholes connect distant points in space-time, they might also connect different points in time. This could theoretically allow for time travel, both into the past and into the future, by traveling through a wormhole. One of the most famous physicists who studied this concept was Kip Thorne. He suggested that a traversable wormhole might allow for time travel, but there would be major challenges, including the need to keep the wormhole stable and open long enough for anything to pass through it. Wormholes are purely theoretical at this point, and we have no direct evidence that they exist. Even if they do, the physics involved in stabilizing them to allow for time travel presents enormous challenges. Theoretical concepts like negative energy may be needed to keep a wormhole open. While time travel to the future might be possible through time dilation, traveling to the past is much more controversial and difficult. According to most physicists, the laws of physics prevent time from flowing backward. One of the reasons time travel to the past is so tricky is because of the paradoxes it creates. For example, the grandfather paradox, where a time traveler could potentially go back and stop their own grandfather from meeting their grandmother, thus preventing their own birth, poses major logical challenges. However, some theories in physics suggest that closed time-like curves, CTCs, could allow for time travel to the past. CTCs are paths through space-time that loop back on themselves, essentially allowing you to travel to your past self. Theoretically, CTCs could exist in certain extreme conditions, such as near rotating black holes or through wormholes. But, much like wormholes, CTCs have yet to be observed in the real world. Black holes are not just enigmatic objects in the universe. They also serve as natural laboratories for studying the deepest questions about time and space. Understanding how black holes work can help unlock the mysteries of space-time and time travel. Through studying black holes, scientists hope to answer questions about the nature of gravity, space-time, and even the possibility of time travel, ideas that have fascinated us for centuries. While we are far from understanding all the complexities of time travel and black holes, the research into these fascinating topics continues. Future missions may one day take us closer to understanding how time works on the most fundamental level. The idea of traveling through time, whether into the future or the past, might not be as far-fetched as it seems. As we continue to study black holes, wormholes, and the nature of space-time, we may one day find a way to explore time itself. Black holes, with their extreme gravitational forces and time-warping effects, are the ultimate cosmic time machines. They offer us a glimpse into the very nature of time and space, and perhaps with future technology, we could one day harness their power for time travel. While time travel remains a theoretical concept, black holes and the study of space-time distortions continue to be at the forefront of scientific research. The possibilities are both mind-boggling and exciting, and we have only scratched the surface. One of the most groundbreaking discoveries in the study of black holes came in 2019, when scientists managed to capture the very first image of a black hole. This was a monumental achievement in astrophysics, as black holes had always been invisible to traditional telescopes. The black hole they imaged was located at the center of the galaxy M87, about 55 million light-years from Earth, and it was a supermassive black hole, roughly 6.5 billion times the mass of our Sun. The image was made possible by the Event Horizon Telescope, EHT, a global network of radio telescopes working together to create the most powerful observatory ever built. By combining data from telescopes across the world, the EHT could produce an image with unprecedented resolution. The image we see is actually a shadow of the black hole, surrounded by a glowing ring of gas and light. This ring is made up of the intense radiation emitted as matter falls into the black hole. This image was not just a visual triumph. It confirmed a key prediction of Einstein's theory of general relativity, that the event horizon of a black hole should look like a dark shadow surrounded by a glowing ring. For the first time, we were able to visually see a black hole, something that was once only theoretical. This discovery has opened up a new era of black hole research, allowing us to study their properties in ways that were previously impossible. In 2015, scientists made another monumental discovery that provided strong evidence for the existence of black holes: the detection of gravitational waves. Gravitational waves are ripples in space-time caused by massive objects like black holes or neutron stars moving through space. When two black holes merge, they send out these waves, and if they are strong enough, we can detect them on Earth. The first detection of gravitational waves came from the LIGO, Laser Interferometer Gravitational Wave Observatory, an observatory designed to detect these incredibly faint signals. LIGO detected the merger of two black holes, roughly 1.3 billion light-years away, creating gravitational waves that rippled through the fabric of space-time. The discovery of gravitational waves opened a whole new observational window into the universe. We can now observe events like black hole mergers and neutron star collisions, events that were previously invisible to traditional telescopes. This technology has allowed scientists to study black holes in a completely different way, measuring their masses, spins, and the dynamics of their mergers. In 1974, physicist Stephen Hawking proposed a revolutionary theory that black holes aren't completely black after all. They should emit a faint form of radiation, known as Hawking radiation, due to quantum effects near the event horizon. This radiation could cause black holes to slowly lose mass and eventually evaporate over incredibly long timescales. If this theory is correct, it would completely change our understanding of black holes and their ultimate fate. Hawking's theory also led to the famous information paradox. According to quantum mechanics, information about the state of particles can't be destroyed. It can only be transformed. But black holes seem to violate this rule. When something falls into a black hole, it appears to be lost forever. This paradox has puzzled scientists for decades. If information is lost in black holes, it would challenge the foundations of quantum mechanics. Most galaxies, including our Milky Way, contain supermassive black holes at their centers. These black holes can be billions of times more massive than our Sun, and they play a significant role in the formation and evolution of galaxies. Scientists believe that supermassive black holes could have formed first, with galaxies growing around them. Alternatively, galaxies may have formed first, and then the supermassive black holes developed at the centers. The powerful gravitational forces from supermassive black holes can influence the movement of stars and gas in their galaxies. This interaction can trigger or suppress star formation, depending on the black hole's activity. When a black hole is actively consuming material, it can release tremendous amounts of energy, which can heat up the surrounding gas, preventing new stars from forming. With advancements in technology, we are now poised to learn even more about black holes. One such project is the Event Horizon Telescope, EHT 2.0, which is aiming to capture more detailed images of black holes, especially those located in the center of our own galaxy, the Milky Way. We are also looking forward to the development of new space telescopes such as the James Webb Space Telescope, JWST, which could help us observe black holes in even greater detail and perhaps provide insights into their formation and behavior. As for theoretical research, scientists are continuing to explore the connections between black holes, quantum mechanics, and the nature of space-time itself. The holographic principle and string theory are two areas of active research that could help us better understand the true nature of black holes and their role in the universe. In the future, we may even discover new types of black holes or uncover new aspects of black hole physics that challenge everything we know. Black hole research has come a long way, from the first theoretical models to the groundbreaking discoveries we are making today. Whether it's through the first image of a black hole, the detection of gravitational waves, or the exploration of Hawking radiation and the information paradox, we are gaining insights into some of the most mysterious and profound objects in the universe. As technology continues to advance, the future of black hole research is incredibly exciting. We are on the verge of unlocking secrets about the universe that have eluded us for centuries, and black holes will likely continue to be at the center of these discoveries. As we look to the future of humanity's space exploration, black holes could play an increasingly important role. While they may seem like destructive forces, they may actually offer potential opportunities for advancing our understanding of the universe and even the possibility of using them for space travel. One potential application is the idea of using black holes to power spacecraft. If we could harness the immense energy around a black hole, particularly the energy emitted by the accretion disk as matter falls in, we could theoretically generate the power needed for interstellar travel. This concept is still in the realm of science fiction, but scientists are researching how to capture the energy around a black hole and convert it into usable energy for space missions. Another exciting possibility for the future is the use of wormholes for space travel. Wormholes could act as shortcuts through space, allowing humanity to travel vast distances in a fraction of the time it would take using conventional propulsion. If wormholes can be stabilized and made traversable, They could revolutionize our ability to explore distant star systems and potentially even reach other galaxies. As we continue to study black holes, we begin to realize that they may play a major role in the ultimate fate of the universe. In fact, some scientists believe that black holes could be the key to understanding how the universe will end. The idea of the Big Freeze suggests that as the universe continues to expand, stars will eventually burn out and galaxies will drift apart. The last remnants of the universe may end up being swallowed by black holes. Alternatively, the Big Crunch theory posits that the universe could eventually collapse in on itself, with black holes playing a central role in this cosmic collapse. As black holes lose mass through Hawking radiation, they could eventually evaporate, leaving behind only the radiation. This process could take longer than the current age of the universe, but it means that black holes, like all things, may have a finite lifespan. In the far, far future, it's possible that the only remnants of the universe will be black holes slowly radiating away their energy until they disappear completely. With the concept of parallel universes and multiverses on the table, black holes could also play a role in humanity's search for life beyond our own universe. Some theories suggest that black holes might serve as portals to other universes, each potentially hosting different forms of life. This could expand the search for extraterrestrial life far beyond what we've previously imagined. As we study the connections between black holes and other universes, we could uncover not just new physical laws, but potentially the existence of life in entirely different cosmic environments. Even within our own universe, black holes could help us in our search for habitable planets. Some black holes, especially the supermassive ones, may have an effect on the formation of stars and planetary systems. By studying the regions around supermassive black holes, scientists may be able to uncover clues about the conditions necessary for life and potentially identify new habitable exoplanets. While black holes may seem distant and mysterious, the study of these cosmic giants has already inspired numerous technological advances here on Earth. For example, the techniques used to study black holes and space-time have led to innovations in imaging technology, data analysis, and even quantum computing. Additionally, understanding the extreme conditions near black holes has led scientists to explore new ways to manage energy, power space exploration, and even create better models of how matter behaves under extreme conditions. In the future, it's even possible that we could create artificial black holes or mini black holes to study the extreme conditions inside them, providing insights into the behavior of matter and energy. By understanding how black holes manage energy on such a large scale, we could create new methods for generating and harnessing energy here on Earth, potentially solving some of our most pressing energy challenges. As we continue to explore black holes and their effects on space-time, we must also consider the philosophical and ethical implications of such discoveries. If black holes can be used for space travel, could they provide a way for humanity to leave Earth if needed? Or could we potentially use them to explore new realities? What does it mean for our understanding of the universe if we can travel through wormholes or manipulate space-time? Would it change how we view time, life, and our place in the cosmos? The study of black holes forces us to confront the unknown in ways that no other scientific discovery has. It challenges our understanding of space, time, and even the fundamental laws of physics. As we venture further into the mysteries of the universe, we may eventually find answers to some of humanity's oldest questions, or perhaps even uncover new questions that we haven't yet imagined. As we continue to study black holes, we unlock not only the mysteries of the universe, but also potential pathways for humanity's future. From advanced propulsion technologies to the possibility of space travel through wormholes, black holes may offer the key to humanity's future in space. They may also hold the answers to questions about the ultimate fate of the universe, the existence of life in other dimensions, and the development of technologies that could change life as we know it. Black holes truly represent the frontier of scientific exploration and human progress. Throughout this video, we've explored the fascinating and mysterious world of black holes. From their mind-boggling gravitational forces to their potential as gateways to other universes, black holes are truly some of the most captivating objects in the cosmos. While the theory of black holes being portals to other universes remains unproven, it opens up an exciting possibility for the future of science. The idea that these cosmic giants could connect different realms of space and time challenges our current understanding of physics and invites us to imagine what might be beyond our universe. Although much of what we've discussed is still theoretical, the potential for discovery is immense. The ongoing research into black holes, from capturing their first images to exploring the effects of gravitational waves, is just the beginning. Who knows what future breakthroughs might unlock even more mysteries? As technology continues to evolve, we may one day be able to observe black holes with even greater precision, or perhaps even find ways to harness their energy or travel through wormholes. There's still so much we don't understand about black holes, space-time, and the universe itself. But one thing is clear: the pursuit of knowledge and the drive to explore the unknown is what pushes humanity forward. As we continue to explore the mysteries of the cosmos, the more we will learn about the nature of reality itself. Perhaps black holes are just the beginning of a whole new chapter in the story of our universe. Our curiosity and desire to understand the universe are what fuel scientific discovery. Whether it's delving into the depths of black holes or exploring other galaxies, it's exploration that leads to the most profound revelations. And who knows, one day, we might even unravel the secrets of time, space, and perhaps even our place in the cosmos. Thank you for joining us on this exciting journey through the mysteries of black holes. We've only scratched the surface of what could be a limitless frontier of discovery. If you found this video interesting and thought-provoking, don't forget to like, share, and subscribe to our channel. We have many more fascinating science topics coming your way, and you won't want to miss them. We'd love to hear your thoughts. Do you believe black holes could really be gateways to other universes? What do you think the future of black hole research holds? Leave your comments below and let's continue the conversation.